So students, welcome to Module 2. This week, we are going to cover two chapters, very similar to the last week. Chapter 3, dealing with data and business intelligence, two very attractive chapters, very informative and foundational chapters. Then we will look into Chapter 4, which covers personal, legal, ethical, and organizational issues. And especially in the modern day of artificial intelligence, machine language, all of these significant concepts that we discuss and review in Chapter 4 becomes a core that we need to have a full understanding on how the impact of technology solutions is going to be presented in the outside world. Okay, so let's dive into Chapter 3. So I'll follow the same method as last week. We'll have two videos, a video on Chapter 3 and a video lecture on Chapter 4. So let's jump into Chapter 3, dealing with data and business intelligence. Now, when we talk about data and business intelligence, we are looking into the pivotal role, the instrumental role that information, data, databases, and analytics play in modern organization. So we'll start by understanding what a database is. Then we'll discuss into the database design. We will also talk about the recent trends that are being applied in this field. Then we will explore into two widely used database, I would say business intelligence tools, Tableau and Power BI. Those are the two tools that have been expanded in the textbook. And these tools are transforming how different departments, different organizations would attempt to visualize and leverage data for decision making. And as we go through this, you will connect the way by which information, data is captured, how it is stored in a very structured manner, and how those archived pieces of information or data can be retrieved and synthesized for actionable insights. So nevertheless, you would understand how different kind of businesses use these technologies to enhance their efficiency and gain the competitive edge. So we talked about the primary purpose of MIS is for institutions to gain competitive edge. So you would appreciate when you navigate this journey, how the different trends and principles behind data and management of data and utilization of data helps in achieving the competitive edge. So let's start now with the foundational of database. If I can find my mouse. Okay. So I think it's the white background that's creating the problem. Okay. So let's take a look at databases. What are databases and database management systems? Now, databases and database management systems, or in short, DBMS, they form the core of every information system, providing structured and efficient way to store, to manage, and retrieve data. So these are keywords: storing data, managing data, and retrieving data. Now let's take a look a step further. A database simply is an organized collection of data, which can include numbers, text, multimedia, and much more. And these databases allows users to store information in a very systematic manner, making it easy to retrieve and use for various applications. So think about online retail store and how database functions in terms of storing customer information, product inventory, transaction that happens during sales, and to ensure that this historic data can be utilized and be available for decision making, for order processing, for replenishing the inventory that has been utilized, all of the different salient functions by which you would be able to successfully operate the retail store. So thus, the fundamental way or fundamental process by which the database management system can be orchestrated in terms of storing and retrieval of data, in terms of securing the data, and an ability to support a multi-user environment, meaning multiple users would be able to interact with the data simultaneously. And storing all of these massive amount of data, depending upon the organization, depending upon the function, also necessitates the backup and recovery of data to ensure the data integrity and availability of data, even when any failures or any infrastructure breakdowns or any server issues that can happen. So storing and retrieval of the data allow users to access information efficiently. Securing the data would protect against unauthorized access and data breaches. We have heard about many stories that happens in data breaches. So this is an evolving field which adapts to all possible ways by which somebody would breach securely stored data, and supporting a multi-user environment, and finally backup and recovery. Now, when we look at some of the key features of DBMS, number one would be data independence. So users can access and modify data without needing to know how it is stored physically. So you need to have like a method by which you can communicate to data, which is stored in the databases. Number two would be like database integrity, ensuring that the data remains accurate and consistent. Number three is concurrent control, meaning managing multiple users who can access the data at the same time. And last but not least is scalability, adapting to growing amounts of data as the business grows, as the organization grows, or as the function grows. Now, let's take a look at some of the real-world applications. So if you focus on an airline booking system, the DBMS would be handling passenger data, flight schedules, ticket sales, and it ensures that only authorized personnel can modify the sensitive information. Customers would be able to book tickets without conflicts in flight availability, and historical records are archived and audited and available for audits for future analysis. Now, DBMS is also a constantly evolving field. We started with like on-premise or on-prem database management systems. The popular DBMS are facilitated by Microsoft, Oracle, and other large enterprise companies. Now, many of the DBMS have become cloud-based. The interoperability by which these databases can be managed has expanded and scaled beyond the boundaries of an infrastructure. So companies like Amazon RDS, or Google Cloud Spanner offer scalability and reduced infrastructure cost, where many organizations are moving their large volume DBMS or database management systems into cloud. Now, we talked briefly about structured query language, or SQL. SQL is one of the methods by which users would be able to interact with the database, whether it is archiving the database, whether it is uploading the database, whether it is transforming the data in the database. All of the different functions can be carried out using SQL. So SQL used to be the traditional language by which different users would be able to connect with different kinds of data. Now we are going into a modern database management system, which would incorporate a NoSQL capability. Because when it came to unstructured data, you can think about data in terms of a structured data or unstructured data. Unstructured data would be large text data where a structure is difficult to define. So social media post or any type of continuous flow of data coming from sensors, even many aspects of big data, they all form as unstructured data. So now database management systems are building their capabilities around NoSQL, where users would be able to interact data in a large volume perspective. With the advent of artificial intelligence, now AI-driven database management systems are also being used widely. They optimize database performance. They would be able to automatically deduct the query by which you are going to ask a database to give you specific aspect of data or information. So there is automation of query tuning and detecting anomalies that may happen during the retrieval, during the uploading, during the extraction time, which would happen in real time, and it automatically correct itself, giving you the power of real time, power of performance, power of scalability, in order for you to run large scale on demand applications. So now when we look into the different ways by which data can be structured, logical database design forms a very key aspect of structuring the data. So you can structure the logical data into different components, and these different components would be able to utilize the consistency, the efficiency, and the scalability of a database design. So the heart of the logical database design is something called as a relational database model. Relational database model, the way the word is coined, it is the relationship between the data that is stored in the database. So these relationships are expressed in terms of data that is stored in different kinds of tables. A table is a representation of series of rows and columns, very similar to how you would picture the data being stored in Microsoft Excel. Microsoft Excel has columns A, B, C, and D, and then you have n number of rows nomenclatured as 1, 2, 3, 4, 5. So it can go up to like million rows or million records, and each record may be characterized in 2 dimensions, basically indexed with like a column and its appropriate row. So in Microsoft, it would be like A1, A5, A15, A10. And each combination of that would be a repository where a small data or information will be stored. Now, there are some key principles when you define or when you design a logical database. Number one is primary key. A primary key is a unique key which can identify one record. So, for example, if you think about a very simple database, like a customer database, where you would like to store information regarding a customer, primarily customer first name, customer last name, customer social security number, customer date of birth, customer address, customer phone, customer email, so on and so forth. So there will be so many Ajit Nayars who would be present in that table. And how do you identify which Ajit Nair you're referring to? So each record representing Ajit Nair with a social security number, with a date of birth, with an address, with a phone number, with an email would be assigned a unique key. So let's say if I claim that unique key as 1339, 1339 becomes the unique key to identify me as Ajit Nair. So that unique key is called as a primary key. And oftentimes it is referred with an ID. So if it is customer table, there would be something called as a customer ID. If it is an state table, it'll be a state ID. If it is a city table, it'll be a city ID, which would be like conglomerate of all cities, conglomerate of all states, so on and so forth. So depending upon the table, these IDs would define a primary key so that it ensures there is no duplicate entries. The second common key that is widely used in databases is called foreign keys. So once you have a primary key that is established in a table, which made the table relevant in terms of querying the data, storing the data, the sanity of the database is kept, which gives you the fundamental ways by which you are able to manage the data. Then comes the concept of foreign key. Foreign keys establish a relationship between the tables by referencing a primary key in another table. So if you have multiple tables, so let's assume we have a table of customers, and each of these customers have purchased several products from your store. And when they purchased products, they created different kind of orders. So let's take an example of a customer table and an order table. So order table would be like an assembly of all of the orders that your store has generated. Now, each of these orders correspond to a given customer. So the way the customer table or the way the order table and the customer table is linked or referenced or related is through a foreign key where the order ID, which is the primary key of the order table, can be mapped to the customer ID in the customer table. Now, when you look at the order table, you don't need to store the entire information regarding that customer again, preventing duplicate entries, ensuring consistency in managing the information. You only refer customer ID. The moment you refer customer ID, you got the handle into the entire record stored as part of the customer. It would include all of the columns that are in that particular customer table, customer name, customer email, customer address, customer phone number, all of those things. Now, the third key terminology that is widely used in databases is normalization. This process of normalization minimizes redundancy by organizing data into multiple related databases. So there will be products, there will be orders, there will be customers. You can have a table only for state, only for city. So different ways by which you can have multiple tables, and relating those multiple tables in a systematic manner becomes normalization. Now, when the customer purchase products, customer can have complaints. So all of the complaints can go into a different table. Now, how do we resolve those complaints? All of the resolutions can be put in a different table. Now, how do we ensure that resolutions are done in a timely manner? So you can relate resolutions, complaints to customer ID, to orders, even to products, what products. All of those different relationships can be established using primary key and foreign key. And that's why this scheme of database model is called as relationship database model. Last but not least is data integrity. This logical design of the data enforces data integrity to ensure that each data that is being stored in the database conforms to the valid data types, whether that particular field can have an empty value or not. Empty value or a blank value is oftentimes called as a null value, N-U-L-L, null value. Whether a field can have null value. So there are different ways by which you would be able to specify what kind of value will be able to go into a particular column. So for example, in the phone number field, if I just want the numbers, I don't want any text, you can specify that this has only numbers, not a text field. In some cases, you want to specify only a date field, you can say this is a date field column. So similarly, you can specify. So in primary key, if you think about it, we cannot have a blank or an empty value. So we cannot have a null record. So it is a not null a rule that needs to be enforced. So if somebody tries to enter a record in the table with a null primary key, it should say that that particular record cannot be saved. So data integrity maintains the referential integrity of that particular table. Now, some of the benefits of logical database design would be definitely data consistency. It reduces duplication. It reduces errors. By the scheme of the data itself or scheme of the table itself, it would manage its own referential integrity. The second advantage would be like the performance. It optimizes the database management systems through logical database design, optimizes how data is effectively retrieved, how data can be analyzed efficiently, and how those can be utilized for decision-making purposes. It also brings us an ability for growth, adapting and evolving to the business requirements without investing money in restructuring the data, restructuring the databases, restructuring the infrastructure, and all of those things. So it brings data redundancy. It reduces the data redundancy, thereby enhancing the data consistency. It enhances the query performance. It is built for scalability. So let's take a look at an e-commerce platform. The logical database design would involve creation of separate tables for customers, for products, for orders, for payments, so on and so forth. And then you establish a relationship between these tables defined using primary keys and foreign keys. The customer table, as we discussed, would store information like name, email, address, and everything. orders table would link to the customer table using customer ID as a foreign key. Order table would have order ID as the primary key, and it manages and maintains all of the orders. Now, when we think about the modern enhancements that is happening in the logical database, now it incorporates artificial intelligence driven optimization. Tools like SQL tuning advisors, they can analyze database schemas or database structures or database, how tables and columns are connected together, and they can automatically recommend performance improvements. They can suggest here are the different ways you would be able to connect these different databases. In a large enterprise system, there will be like hundreds and thousands of tables, and it's very difficult for someone who is not constantly looking into these kinds of data to keep track of it. So AI helps in optimization. Now, there are also hybrid systems which combine relational structures with the NoSQL capabilities so that it can handle unstructured data. So we talked about structured and unstructured data. So by focusing on logical database design, businesses can ensure that their databases are efficient, reliable, and ready to support sophisticated analysis and decision making. So now let's take a look at some of the components of the database management system. So there are 5 key components that you need to understand from a database management system. Number 1 is database engine. Database engine forms the heart of the DBMS. It is responsible for storing and retrieving data. Number 2, data definition. Data definition brings how the database is structured. It gives us information regarding tables, fields, or columns, and how those columns or tables are related to one another. Number 3 is data manipulation. It allows users to query or ask or update the existing tables or change the data. So query, update, and change the data. Then you have application generation, where you would be able to utilize tools for developing user-friendly database applications so that you are not touching the database directly. You're utilizing the checks and balances provided by the application to interact with the database. Last but not least, you have data administration to ensure the security, the backup, disaster recovery, the performance of that particular database or a swarm of databases. So if you take financial institutions, banking system, you can imagine the intensity of the database engine processing account transactions 24/7, 365 days, and also to ensure that the data administration goes through compliance, regulations, it safeguards against any breaches, it protects against any type of violations, and it also makes sure that it has all of the latest and greatest infrastructure adaptations that continuously scale and monitor data. So once you have these 5 principles managed, you are ready to go through and ensure that there is a scalable database management system in place. Now let's take a look at some of the trends in database design. So this database design, as I mentioned, is continuously evolving. Why? Because the demand for data and the demand to make data available and the demand by which data is generated in different forms and fashions is forcing the database management system to grow, to scale, to bring speed, to bring flexibility, all of those things, right? So let's take a look at some of the different ways that is database management systems is evolving. So when you take a look at Netflix, Amazon, they're all data-driven websites or data-driven web applications or platforms. They're built on dynamic data-driven architectures. And these systems constantly retrieve data from databases in real time to bring that personalization for all of us so that it gives us rich user experience. It knows about us. It knows about our favorite movies, favorite products. It can even predict which would be the next movie that we are going to watch or next show that we are going to watch or any product that we are even thinking about. So product recommendations and constant suggestions based on personalized behavior and preferences would be the characteristic of these data-driven websites. Popular Amazon, Netflix, Walmart. So any type of large e-commerce platforms all depend upon these data-driven websites. Then you have distributed databases. So these databases store data in multiple servers and in multiple locations. And this design ensures higher availability, scalability, and fault tolerances. Meaning, today I might be accessing the Amazon website sitting in Houston, Texas. Tomorrow, I will be in Netherlands, and I want to take a look at whether my order is being delivered or not. So if the database server is located in Houston, me being in Netherlands, the latency by which the data that can be retrieved, queried, and presented back to me would take a longer time. So having databases in different countries, different states, different cities, closer to where the user is accessing would prevent lag, would prevent the delay for users to access the data, enrich the experience. So higher availability of the data and to ensure that the data can be presented in as accurate as possible with absolutely no delay would become the core theme behind distributed databases. So typically companies who operate in global operations, they may be other than the Amazon or e-commerce applications, multinational banks, wherever we go, we have capabilities to withdraw money or do financial transactions at a global scale. They all rely on distributed databases to ensure there is continuity of service, even if one server or multiple servers can go down. The third would be object-oriented databases. So unlike the relational databases we talk about, where data is stored in different tables, columns with primary keys, foreign keys, maintaining the referential integrity, these object-oriented databases store data as objects. So it can be a multimedia, it can be videos, it can be CAD files, it can be large images. And these are ideal for industries like gaming, engineering, medical imaging, where complex types of data, videos, images, large industry designs, and these data types are very commonly used. So they are formed or they are commonly called as object-oriented databases. Now, we talked about NoSQL databases. So when the volume and variety of data increases, the NoSQL database have emerged as an alternative to relational databases. So these NoSQL databases are particularly useful for unstructured or semi-structured data, such as analyzing social media posts or a continuous data being produced from sensors. We talked about Internet of Technologies or IoT enabled device data. Some of the popular NoSQL databases, they're called as MongoDB or Cassandra. They are leading widely used NoSQL databases, which can be used in cloud platforms, different kinds of cloud platforms. Then there is hybrid database, as you may have rightly guessed. They may be the combination of relational and NoSQL databases forming hybrid solutions. They bring the flexibility to handle both the structured and unstructured data. So in a complex, large-scale business environment, you can imagine there would be structured data, there would be unstructured data, and these hybrid databases brings the capability to handle all of the different capabilities. They can look at the financial transactions. They can also look at the customer sentiments or customer emotional appeal or customer satisfactions, customer engagement, so on and so forth. All of those unstructured qualitative data can be effectively stored, analyzed, and be presented for decision making. Then you have database automation. So the modern database management systems, they increasingly start adopting automation powered by artificial intelligence. And these systems would be able to automatically optimize queries. They will do automated backups. And if there are issues, they can also detect proactively, bringing all of those security concerns, data breaches, or any type of anomalies to a certain decision-making roles and responsibilities so that it can be dealt with before something major happens. So now think about a global streaming platform like Spotify. Spotify would use a different combination of distributed databases for their real-time data retrieval so that the personalized playlist to millions of users can be given simultaneously. And this rich, seamless experience relies on cutting-edge database design principles and automations to ensure the reliability and speed. Now let's take a look at data warehouses. So data warehouse would be, let me make sure I have the mouse. So data warehouse is a critical component. As the word says, warehouse. It's a large volume of data being stored in a repository. That's called data warehouse in simple words. It's a critical component of modern business intelligence strategies. It serves as a centralized repository that integrates data from various sources, making it possible to perform comprehensive analysis and generate actionable insights. So the key components of data warehouse would be an ability to input, meaning data warehouse collect data from multiple sources. So this would be from a customer relationship management system. So the customer relationship management system would have one or many databases. Then you would have enterprise resource planning system. An ERP system would have multiple databases. Then you would have several transactional databases, which maintains the real-time on-demand transactions. And then there will be like databases to manage the social media post, market research, market trends, all of those things. So imagine a large enterprise system with different functions and each of the functions would have different kinds of databases. So from all of these databases, the data will be collected and stored in a very systematic manner in a large data repository called data warehouse. So data warehouse, oftentimes you would hear ETL process. ETL stands for extracting, transforming, and loading. Extracting would be gathering the raw data from different sources. Transforming would be cleaning, organizing data to ensure consistency. So there is no duplicates. The customer ID of Ajit Nair refers to Ajit Nair living in Houston, Texas, not in Ajit Nair living in Netherlands. So ensuring that the reliability of the data is dependable would be the role of transforming process, and then loading, storing the processed data into the warehouse for analysis. So extract, transform, load is a very commonly used process to ensure that you have clean, authentic, validated data that has been made available in large data warehouses. When you look at storage, data is stored in structured and optimized format, which often uses different kind of technique like columnar storage techniques to ensure that the query that you are utilizing can be ascertained in maximum performance and efficiency. Since there are gigabytes of data that have been stored, or gigabytes or terabytes or petabytes of data that has been stored, you want to make sure that when you do a query, the performance is optimal, by which you can answer the questions in a reasonable real-time way. Then comes the output. The data warehouse provides a structured, processed data to business intelligence tools, to your dashboards, to the different kinds of reports that you create, enabling that real-time or historical analysis or the answers to the problem that you're trying to solve. So what are some of the benefits of these large volume of data stored in this huge repository of data warehouses? Number one is historical data analysis. By consolidating years of data, businesses would be able to identify long-term trends, their patterns, opportunities to improve, evolution of businesses, customer demands, different kind of preferences. All of this lead to improved decision-making. Imagine you as a leader of an organization now have access to reliable, up-to-date information for your strategic planning. It also brings scalability. So we talked about modern cloud-based data stores. There are cloud-based data warehouses like Snowflake or Google BigQuery. They offer scalable solutions to meet the growing data demands. So Snowflake and Google BigQuery, they become very common when you are in that field, when you're interacting with even smaller companies who are utilizing cloud-based infrastructure at an optimized cost. So now if you consider a large retail chain, which operates in multiple regions, the data warehouse would consolidate the data coming from all stores, which allows the corporate headquarters to analyze seasonal trends across their stores, across the product suite, across the customer portfolios. They can look into the regional performance. They can forecast the inventory that is needed by specifically for stores or across all of those stores. So they might notice that certain products sell better in specific regions, maybe during winter or during summer, so that it enables to adjust the inventory levels and marketing efforts optimally. There are now several tools even to study this. Machine learning brings in predictive analytics for bringing the automated insights coming from these data. There is real-time data integration to support sensitive decision making, such as dynamic pricing, or even like security breaches or fraud detections. Now we have different kinds of concepts called data lakes, data rivers, and all of those things, which complement warehouse by storing unstructured data for broader analysis. So in short, adopting robust data warehousing strategies, organizations would be able to ensure that their data is not only well organized, but also primed for delivering actionable insights. Now let's take a look at data mart. So data mart are specialized smaller subsets of data or smaller subsets of data warehouse designed to serve a specific business need or a departmental function. So the way it's very interesting, all of this starting from relational database, folks have paid so close attention to nomenclature each of these concepts, each of these software tools, entities, in a manner by which common people like you and me would be able to interact and understand very effectively. So data marts are nothing but a smaller subset of data warehouses. And once you focus on targeted data, data marts can bring much faster and much more easier accessibility to insights or specific user groups, whether it's marketing, whether it's finance, whether it's sales teams. So data marts can efficiently organize a limited set of data for the enterprise and bring all of these innovations in the forefront. So some of the key features should be in a data mart it should be like a purpose built. There is a particular function that they are focusing on. And given it is smaller than the data warehouses, the responses from data mart would be like much faster. Queries can be executed much more efficiently as compared to a large scale data warehouse. And since the structure and complexity is much less, it also makes it much easier for even non-technical users to access and interpret the information. So there are dependent data marts as well as independent data marts. Dependent data marts are created by extracting data from a centralized data warehouse. So for example, a marketing data mart may extract campaign performance metrics and customer demographics from a company's central data repository. Whereas independent data mart would be independently of any type of data warehouse. They can collect data from any sources independently. A sales data mart may pull information directly from a customer relationship management system or an ERP system, or even like from marketing system to track the performance metrics. Now, since you have independent and dependent, very naturally you need something in between as well. So they would be called as hybrid data marts. They would combine characteristics of both dependent and independent data marts. They allow more flexibility of integration from a central data warehouse perspective, as well as external data sources. So when you look at healthcare organization would have clinical research, academic or teaching, finance departments, then medical records departments. They all use some kind of data mart to track billing. So finance would be using the data mart for tracking billing. whereas clinical research team would utilize data mart for patient outcomes, clinical trials, so on and so forth. Now, you can compare different kind of data marts to the basic needs of the department. And you can also orchestrate a good streamlining decision-making process for those data marts. So it might be defined based on the scope, based on the cost that somebody has to bear for these data marts, and the speed by which the querying of the data mart can be made faster due to the smaller size. With similar to the rapid expansion that's happening in the industry, there are cloud-based data marts. For example, Amazon has Redshift as their data mart. Microsoft cloud service provider Azure or Azure infrastructure, they enable organizations automatically to set up scalable and cost-efficient data marts based on the demand. AI and machine language play a very, very key role in all of these data marts. We talked about data lakes. Now we have data lakes and data marts. All of the modern infrastructure and architectures enables the storing of structured and unstructured data so that a comprehensive analytics can be extracted by looking into these different kinds of information stored as databases. Now let's take a look at business analytics. Business analytics pretty much combine all of the functions that is used in organizations for transforming these raw data into actionable insights. So that particular function where you have the raw data stored and how do you derive actionable insights becomes the scope of business analytics. Business analytics empower organizations to make strategic decisions in order to drive growth, in order to bring competitive edge, in order to expand, or in order to even withdraw and make sure that you make intelligent decisions when you deepen your strategy. So by leveraging different kinds of tools, techniques, and technologies, business analytics enables companies to stay competitive in this dynamic data-driven world. So let's take a look at a few types of business analytics. The first and the basic one would be descriptive analytics. So descriptive analytics answers the question, what has happened? It refers to the past tense. It focuses on summarizing the historical data to understand the past performance and trends. So anytime you need to understand what has happened in the past, that set of analytics is called as descriptive analytics. So in descriptive analytics, we use different kinds of techniques. Data aggregation, data mining are common techniques that are used in descriptive analytics. We also utilize statistical methods, very similar to even the common methods like averages, percentages, and trends. They're all used for understanding what has happened in the past or describe events or describe insights about the past events. Anytime you hear about dashboards or scorecards, they're all showing what has happened in the past. So they're all techniques used to describe or to present the descriptive analytics. So why is descriptive analytics important? It is extremely important to understand, depending upon the company, the trends and the behavior and experience. So if it is a retail company, you need to analyze the sales trends, maybe quarterly, half-yearly, yearly. If it is a web platform, you need to monitor the web traffic, the behavior of users, If it is customer service, you need to look at the customer service survey scores, understand the customer satisfaction, gauge the customer experience for a particular store, a particular product. So there's different ways by which descriptive or historical or what has happened in the past can be understood, converting the raw data into deeper insights called descriptive analytics. Now let's take a look into future. What is likely going to happen? That's called predictive analytics. So predictive analytics uses future or forecasting or statistical models or machine learning algorithms and historical data to forecast future outcomes. What is the likely thing that is going to happen? Three major ways by which popularly one can use a prediction is utilizing regression analysis. There are different kinds of regression analysis that has been used to predict the future. Then you can also use time series forecasting. So if there is a time series dependency of events, then you can see how the trend is changing on a weekly basis, monthly basis, quarterly basis, half-yearly basis, annual basis, or multiple years, 1 year, 3 year, 5 year basis. Now, there are series of machine language models which can predict and bring analytics very effectively to you, empowering your decision makers with deeper insights. So forecasting customer demand for a set of products, predicting the customer churn for subscription-based business, anticipating even the stock price changes on different market conditions all becomes part of the predictive analytics. Now let's take a look at the next step. So we looked at the historical description, what has happened in the descriptive. We also looked at what will happen, or what is the likelihood of something happening, becoming the predictive. The third one is prescriptive. What should we do? Based on predictions based on current and historical data, what should we do? Like, how do we respond to those predictions? So prescriptive, very similar to what the word says. Like when you go to the physician writes the prescription, this is the medicine you should take. So there is no, you don't have to predict or you don't have to describe. The physician has already described. The physician has already predicted, and the physician is now prescribing, this is what you should take. Very similarly, prescriptive analytics recommends actions based on predictions to optimize decision-making and outcomes. So techniques that are used would be like different kind of algorithms. These bucket of algorithms are called as optimization algorithms. Then you can use very systematic way of prediction, or not prediction, prescription, called decision trees or simulations. Because when you simulate, you would be able to learn more deeper the outcome and the decision making and the impact of making those decisions. So that also leads us to scenario planning. So you can create different kinds of scenarios, run through the scenario, you gather the outcome, you select the right outcome, you then decide what combination of scenarios can be utilized to produce the desired outcome. That becomes the core components of prescriptive analytics. So descriptive, happening in the past; predictive, what is going to happen in the future; prescriptive is what should we do. So prescriptive example would be a logistics company. They would use prescriptive analytics to determine the most cost-effective routes for delivering trucks, saving fuel cost, or reducing delivery times. Prescriptive analytics is also heavily used in order to guide you through GPS when there is a traffic block. It will suggest alternative routes for you to go into different pathways by which the faster and optimized reachable time can be achieved. Now let's take a look at outside of descriptive, predictive, and prescriptive, what are some of the emerging types of analytics? The most common one that comes to my mind is called diagnostic analytics. So diagnostic analytics goes deeper into the data to understand why something has happened. So meaning the question that diagnostic analytics would answer is, why did it happen? Okay. Now today we use very commonly called as root cause analysis. When an event happened, a most common first measure is to understand the root cause of why this happened once the mitigation steps are all covered from that event. So diagnostic analytics would be able to go deeper into that root cause analysis, or it can use a drill down or data discovery tools so that why a specific event has happened. Why did the specific marketing campaign underperform? Why didn't the customer churn happen as predicted? So then you also have something called as a real-time analytics. Real-time analytics gives you insights and decisions in what is happening right now. Using event-driven analytics, using streaming data processing, you would be able to understand what is happening right now. So what has happened, descriptive, what is going to happen, predictive, what should you do, prescriptive, why something happened is diagnostic. Now, let's assume there is a fraud or a security breach happening right now. You need to monitor it immediately. You cannot think about past, you cannot think about future. You do not have enough information to what should you do because it has not happened yet. And you cannot even go and understand what, from a root cause perspective, like what should you do? So real-time analytics gives deeper insight into activities that are happening at this point of time. So it can be any type of security breaches, fraud detection. You can also understand the customer sentiment, social media sentiments, customer sentiment. Before that particular sentiment complete, you will be able to utilize the real-time analytics to derive where this is going. So some of the real-world applications would be in retail. They use predictive analytics to forecast the demand, which is absolutely needed, because that would help optimize the inventory, enhance the customer experience, and bring those personalized recommendations to them. Whereas in healthcare, hospitals most of the time rely on descriptive analytics to look into the patient records, to identify the treatment success rates, and constantly strive to improve patient outcomes. In financial institutions, prescriptive analytics is utilized to detect fraud, any type of credit risks, personalized financial plans for different kinds of customers, so on and so forth. In sports, teams use real-time analytics to assess the performance of the game, optimizing the game strategies, and even predictive analytics to assess the risk behind injuries. So business intelligence is a very, very attractive field where all of the emerging modern technologies and business analytics relies on different kinds of tools. So the textbook recommended tools, Tableau and Power BI, both of them are continuously going through these changes. These platforms bring interactive dashboards by which data visualizations and other advanced capabilities makes it easier for decision making or decision makers to interpret complex data sets. So we will look into these tools later in this chapter. So in summary, the biggest benefits of business analytics would be enhanced decision making, operational efficiency, maintaining that competitive edge, mitigating any types of risk that's happening. AI and machine learning are continuously automating, bringing more and more capabilities to these different kinds of analytic processes. Big data integration combines the structured and unstructured data sources, which brings deeper insights. I don't think I discussed this. Natural language processing. Natural language processing is an emerging field which often utilized by AI and ML. It, as exactly the word suggests, it allows systems or machines or computers to interpret and respond to human language, making data more accessible, more meaningful, less technical, so that you have different kind of users interacting with natural language processing or NLP tools by which they would be able to understand the deeper insights behind the business. So when you think about the future of business analytics, it will continuously grow. There will be a huge infiltration of different kind of technologies to enhance the business analytics. It is fundamental for any organization by which they can understand the raw data and extract the deeper insights by which they would be able to grow and position themselves for competitive advantage. And those companies that effectively integrate advanced analytics will have a distinct edge in innovation, customer engagement, and operational excellence. And by leveraging the different power that organizations can utilize from business analytics, they can make smarter decisions. They would be able to discover hidden opportunities. They would be able to prepare for future challenges, as well as they are ready to bring in complex and data-driven environments. And they would be able to scale based on the demand from their customers. So connected with the same topic, going through that same theme, would be the big data and predictive analytics. They are literally revolutionizing the field of database management systems, capabilities of companies and human beings to understand the deeper trends, anticipate challenges, and drive decision making. So big data, as the terminology indicates, it refers to extremely large and complex data sets that traditional data management tools or relational databases will not be able to handle effectively. And these data are generated from various sources. They include structured data, meaning data organized in relational databases or kind of relational databases, which would be like customer data, sales data, financial transactions. Now, it can also handle unstructured data from emails, social media, images, videos, large blogs, or it can utilize semi-structured data. There are different kind of markup languages like XML or IoT sensor feeds. So there's some structure, but it's not fully structured. It includes both. That's why it's called semi-structured. So structured data, unstructured data, semi-structured data, all of those can be handled by big data. The characteristics of big data can be summarized in 5 V's. So number 1 V is volume, because it's massive amount of data generated continuously. Number 2 V is velocity, the speed by which the data is created and processed. Number 3 is variety, depending upon different types and sources of data, structured, unstructured, semi-structured, you have different variety of data. veracity, the reliability and quality of data brings the veracity for big data. And finally, the value or the actionable insights that can be derived from analyzing big data. Now, predictive analytics, we touched on predictive analytics. Some of the key steps in predictive analytics is make sure that there is a very systematic way by which you're collecting the data, you're aggregating the data from internal and external sources. More than reflecting on my experience in predictive analytics, the maximum amount of time would be devoted for data preparation because you are collecting and you are organizing the data for analysis. That's where you are deeply connected with the questions you are trying to answer and the nature and relevant of the data that is needed to answer those questions. Then you can use different kinds of models, regression models, neural networks, or different kind of models that can be used to create forecast or predictions. Then you're testing those predictions for accuracy to make sure that it is relevant. It can stand the litmus test of different variables or different kind of environments. And finally, you would be able to deploy these models for real world decision making. So there are so many predictive analytics utilized in retail, primarily for predicting customer preference, personalized marketing campaigns, healthcare, looking into patient readmissions. Will the patient come back to the hospitals for payers? How do they improve the different kind of care plans? In finance, detecting the fraudulent transactions in real time. In manufacturing, forecasting equipment maintenance that are needed to prevent downtime. Now, when you combine big data and predictive analytics, there are so much value that somebody would derive to uncover patterns, to gain insights, to make proactive decisions. So very commonly utilized applications that we interact would be like ride-sharing apps. Platforms like Uber, they use big data and predictive models to anticipate demand. Where is the demand surge? Where is the demand coming down? And they can allocate the resources effectively. Smart cities are yet another way by which big data and predictive analytics is being utilized, where government would be able to analyze traffic and utility data to optimize urban planning. So, when the benefits of big data and predictive analytics, as we discussed, making sure that decision-making optimization has been achieved, operational efficiency, and mitigating some of the risks that can happen when you operate different kind of processes. So now let's take a look at the common business intelligence platforms, Tableau and Power BI. Power BI is a Microsoft business intelligence tool, much more economic compared to Tableau. There are very two popular tools which are widely used for data visualization, analysis, empowering organizations to make sure that the decisions are supported by deeper insights coming from data. Tableau, I would say like both tools are very, very compelling and very similar. They all use drag and drop capabilities, advanced visualizations, different kind of capabilities to connect to different data stores. The biggest value add for Microsoft is if you're a Microsoft shop, it can interact seamlessly with the Microsoft Excel and other Microsoft data stores. It's much cheaper compared to Tableau. So the sales team, in our organization, we use both Tableau and Power BI, depending upon different situations and depending upon the visualization capabilities that lead to either choice of Tableau or choice of Power BI. So that brings us to the tail end of chapter 3, data and business intelligence. So when we look at the conclusion of this chapter is a very intense chapter. It covered a lot of fundamental aspects of in managing organizations to ensure that there is data-driven capabilities built, solid understanding about databases and their role in business analytics. We looked into the databases, how it is designed, how it is managed. We also touched base on all of the relevant latest and greatest changes happening in database technology. And finally, we looked into Tableau and Power BI, which bring data into life through visualization. So think about how these concepts would apply in real world scenarios and how in your businesses or the companies that you work for would be able to harness the power of data to stay competitive. So I would record chapter 4 as a separate video. Thank you very much. This is a very, very fundamental chapter to read, understand, and making sure to reflect on what is happening in the industry at this point of time. Thank you, everybody. See you in the class.